Hi, so welcome to this extra video on week 4. Um, this is a video that wasn't included in last year's version of the course, but I wanted to include it because I think it is some useful information that hopefully will save you time later. So this is one more video than last year's cohort had to watch, but hopefully it will save you time. So it's a net benefit. And what we're going to talk about is a way to import data into our studio using what's known as its GUI or GUI. And that means the first question I have to ask to answer, is what is a GUI or a GUI? And it stands for Graphical User Interface. And you use these all the time, and we've been using one already. So our studio provides you with lots of buttons that you can click, as well as the option to type in commands to R. And that's the Graphical User Interface. So these are things that you can do outside of just having to write R code in order to do things within our studio. And that's part of the point of an IDE, an integrated development environment like RStudio, is that it gives you this extra functionality to help you with your coding. And so I just want to tell you about one bit of functionality here, which is that it lets you, it gives you some helper functions, some helper dialog boxes to help you import your data. So let's start with one example of that, which is a CSV file. Most data that you'll come across will either be in a CSV format or in Excel format. So we'll start with CSVs, we'll talk about that for a while, and then we'll talk more quickly about Excel. So we've already talked about the read_CSV function that's provided by the tidyverse. And it has various options that you can pass to it, and there's a family of functions as well, like read TSV for tab separated values. But the options are a little bit fiddly. And this is especially true if you have datasets with lots of different variables, fairly wide datasets. You might have to look at sort of the data type for every single column and pass that to the function. And you also usually have to inspect the dataset manually to get it absolutely right. First time at least, you need to open it in a text editor. So double clicking on a CSV file will usually open it in Excel if you have Excel installed on your computer. And that's not going to help you. You need to right click and open it and say Notepad, or open it through RStudio so that you can actually see what delimiters are used between the values. So let's just see what happens if we do plow ahead with something that's maybe a little bit non-standard in its specifications. So I made a little dataset, a toy dataset called Tube. It has some information about tube stations, like I've picked 8 of them, and it says which line they're on, which zone they're in, and things like that. And I've tried importing it, and it says that there are 2 columns, but that's weird because you can see on the screen there 5 variables. There actually should be 6, I think. No, there are 5, but definitely more than 2. And something's gone a bit wrong. So it's not entirely clear what's wrong here. You might be able to guess from that first line, but if we look at what it's actually imported, we can really see what the problem is. And that's that the separators here are not commas. RStudio has assumed that they're commas, and in fact they're semicolons. The reason that I encoded them when I was making this dataset as semicolons is that some of the data points actually have commas in them. So like one of the stations is Heathrow Terminals 1, 2, 3, and that has commas between the names, between the numbers at the end. So we could here just use read CSV2. That's the command that lets you read semicolon separated files. But then we have to remember what CSV2 is and so on. So maybe there's an easier way to do this. So the easier way through the GUI is to go to the import dataset option. You'll see that at the top right by default. So wherever you have the environment tab and the Git tab that you've probably been using, under the environment tab, you'll see an import dataset option. And under there, what you want to do is click on from text brackets reader. So reader makes sure that it's importing using the tidyverse functions rather than the base functions. And they're usually a little bit faster, the tidyverse functions. So it's worth going for those, especially if you have a large data set. But yes, if you click on from text reader, what then happens is you get this box appear. It's fairly blank at the moment. And the first thing we need to do is click on the browse button that's here. Because what the browse button does is it lets us choose a file, choose a data file that we want to import. So let's do that. And if we're on our Studio Cloud, it will show us the files that we uploaded to our particular project. And if we do that, what we see is something like this. And this is very much like what we had before. It's put a comma, it's decided that they were comma separated. Our title thing, it's split at a comma here. So Millions 2019 was part of the title of that column. And it's split at Heathrow Terminals 1, 2, 3, but it couldn't find commas in the other rows. So it just put a load of NAs in. That's clearly wrong. The first thing we can do is down here at the bottom, it says delimiter comma, and we can change that. Click on that and change it to semicolon, and already this is looking much, much better. There's still a couple of NAs, but I think at least one of those was present in the original data. But you'll also notice that it has these data types at the top, and it actually says, the last column is a double, which is right, but it says everything else is a character. And that's not really right. The opened column should be a date, and the zone column should be a number as well, because those are integers that have some meaning, right? They're not just labels. Zone 1 is the innermost zone of London, if you know if you've looked at the tube map, and zone 2 is the next one out, and so on and so forth. But for different reasons, it's decided that these aren't. So it's not quite worked out that these are dates, and it's also got a bit confused by the fact that one of the zones is not in a zone. And it's just decided, oh, well, that's a character, that's a text string, so I'm going to have to say these are characters. And we know that should be an NA. So actually we can click on those data types, and if we do, we can change the zone column to integer, and we can change the character column to date. Now when you do the date one, you'll get another little box appear, which is like this, and it asks you to enter the format string. And this is where this gets a little bit technical, so feel free to not worry too much about this. I'll give you an alternative for use with dates in a minute. But in particular, what that means is that it thinks that date is in numeric format with a 4-digit year. That's why capital Y. And it thinks that it's month in numbers / day in numbers / year as a 4-digit number. Our dates are not of that form. Our dates are of the form date in numbers hyphen month, like abbreviated month in letters, and year, a 4-digit year. And so the thing we need to type is %D hyphen %B hyphen %Y. If you type $col_date into the console, you can see what those different codes are. I'm not going to go through them here because there is an easier way actually to do this, which is if you're having trouble getting dates in through the box. I said that this was supposed to be a way to make things easier for you, and if this is just making it harder, what you can do is, in fact, treat dates as characters for now, and then use the functions from the lubridate package that Mina talked about in her videos. So for instance, dmy would be the function here, and dmy will be able to just work it out. It's clever enough to do that. This function isn't so clever. But anyway, if we do that, as I've said, if I change that with the date format, now it can recognize everything. And if we look at the table at the top, that's all looking good. All of the data types are correct. The non-integer zone has become an NA. It's managed to work that out. And that's actually a little bit lazy, really, as coding. We're going to get a warning later for doing that, because we've sort of coerced that into NA type. It's just, we've told it it's an integer, and it's gone, oh, I can't interpret that as an integer NA. And that's kind of lazy coding practice. R doesn't like it when you do that necessarily. You can just proceed, but perhaps better would be to explicitly specify NAs. And yeah, you can do that manually, taking in a minute. We'll talk about that in a sec. One thing to notice though is that not everything that we might treat as an NA has been removed. And you might think, oh, well, those all look right, but just look closely at the Battersea Power Station row, and you'll see that this station, so our variables are the station, the line it's on, which zone it's in, the date it was opened, and the number of passengers in 2019. And you'll notice that this date is the year 3000. And it's the 1st of January in the year 2000, New Year's Day. That doesn't seem right. And also the number of passengers there, which is a bit of a clue, is NA. And the reason for that is at the time I compiled this data set, but probably not by the time you watch this video, that station hadn't opened yet. So whoever made this data set, i.e. me, decided that I was going to encode dates that were essentially NAs as dates in the future, and you will sometimes see that that happens. Um, and that's a little bit annoying. Um, so we're going to have to manually remove that later, because there's no way that this dialog box can work out that, yeah, that's a date, but it's not really a date. You know, maybe there is a legitimate reason in a data set to have dates in the year 3000, and that's context dependent. So that's going to have to be dealt with later. Now, we could run our code directly from the dialog box, but that's not going to help us when we're trying to make an R Markdown file. The whole point of an R Markdown file is that it's sort of all contained in one file, and we can the code is portable. You know, we can send that to somebody else and everything will work. And if we just run it locally, if we just run that code, yeah, it's imported for our session, but then later when we try and knit the thing, or if we just send some raw code to somebody else, if that's not included in the file we send, that's not going to work. Fortunately, there's a way around this. There's a little clipboard button there. And if you click that clipboard button, it will copy the code and you need to paste that into your R Markdown file. So I did that. And if we look there, now I just turn off my camera so you can see this. You'll notice that the code has been, I've tidied up the code a little bit, so I copied it and then put some different line breaks in line with tidyverse style guides. It's also given us, in the stuff we could copy, the reader package or library. It's given us that for, like, as an extra line because it knows we need that. But we don't actually need that if we're copying it into one of our RMD files, because we've usually called library tidyverse, and that includes reader. So I've commented that line out to say we don't actually need to run that here, and in practice you just delete that line. So there we go. That should be importing this as the name tube_stations, and we can check it worked. Because if we try and run a summarize statement on this, this now works. It's telling us there are some parsing issues, firstly. And you can run, those are parsing issues with importing data, so we can run problems brackets tube_stations to see what those are. And yeah, what it is that it doesn't like the fact that we've tried to change, decided that not in a zone is an integer. So you could modify the code to specify NA specifically. Other than that, it seems to have worked. We've got a date as our mean date, and we've got a zone, a plausible zone as our median zone, and this seems fine until, if you look more closely, our mean date is in the year 2056. And that doesn't seem right, our mean date of opening. And if we think back, that's because I said that we had a date in the year 3000. So unfortunately, we've been busted for our laziness, and we've now got an incorrect answer. So what we're going to have to do, we're going to have to go back and manually fix that before we can actually do any of our analysis properly. So this is a bit of a cautionary tale. Firstly, to say that we're going to get these warnings coming up if we're a little bit lazy with NAs, and secondly, if some things that really are NAs might be interpreted by this graphical user interface option as real data, and that could throw off your analysis. So I'm saying this just to say this is to make your life easier, and hopefully it will. It will give you some code that's a starting point, but you may then need to modify that code a little bit or do some extra things. So for instance, if you had dates you couldn't pass, run a lubridate function to convert them with a mutate statement, you may have to do extra things in addition to this, but hopefully this is just an easier way to get started. So let's talk a little bit about Excel files. So let's see our data now in an Excel file. I've actually removed one of the rows from the dataset. There's a limitation of Excel. Excel can't handle dates before the year 1900, which is one reason maybe not to use Excel if you're dealing with historical data. There may be a way around it. It's not one that I know of. It also thinks the year 1900 is a leap year, which it wasn't. And that's because some old bit of spreadsheet software did that, and for backwards compatibility, every subsequent version has had to treat the year 1900 as a leap year. So I've removed the station that was opened in the 19th century, but the others are still there. Yeah, if you really had Excel data, you'd have to find a way around that, but since this is just an example, I took it out. So now we're going to want the from Excel option, and it's going to be something very similar. We get a box like this, and we get a page like this when we import the data. So what's wrong here? We didn't have to worry about delimiters or anything, and It's done something weird with our opening. It thinks they're characters, character vectors, and it gives them all a number. So Russell Square is 2541, which I think is roughly the number of days that date is since the beginning of 1900. I think that's what's going on there. It's just the way Excel stores data. But the really key problem here is that it's done something. If we go back to the Excel file, you'll notice there's those rows that say tube station data and some tube stations only that are title rows that have been spread across all of the rows, and it doesn't like those. It's tried to import those as data, and what it's decided is that column 1 is called tube station data with first entry some tube stations only, and then the other columns don't have names, and it's all a bit of a mess. The problem here is that we need to tell this function, and we need to do this even if we weren't using a graphical user interface. We need to tell it, if we're importing from Excel, which cells our data are in. So we can do that in the bottom left box there. We need to specify the range of the cells or use that skip field. That skip is the alternative. It lets you skip certain rows at the beginning. The other thing we've changed here, which we didn't touch the previous time, is the name field. And I've changed that because name will default to the name of the file that we're importing, but or something related to it that fits with R's object naming rules. But unfortunately, tube stations is already taken because we had tubestations.csv was what we imported as the object tube stations, and we're now trying to import from tubestations.xlsx, and we can't call it tube stations again. That's gone. If we tried, it would just overwrite it. So I've changed that to tube stations XL. But once we fix the range, now this is looking a lot better. We need to fix the data types potentially as well, but those dates really are dates. We haven't been given separate separate options for double and integer. We've just got a numeric option here. We can fix that later if we are really concerned about it, using a mutate statement again. The dates we don't have any problem with because Excel already understands dates reasonably well, and readXL can convert from that, so that's fine. So this is looking quite good now. And we can copy this out. We get some code at the bottom right again, and we can click on the clipboard icon and copy it out. So let's do that. I've cleaned it up a little bit, and that's the code we get. So it does give us a lot of warnings when we run this, because every time it's changing the type of a cell from whatever Excel had it as, it gives us a warning. Those are going to look quite messy, potentially on your RMD output. So what I've done, if you know, you have little code chunks in an RMD document. In the RMD document I used to make these slides, I actually put the warning equals false option as the label of the label of the code chunk. That will stop it from printing the warnings. So there you go. That's a couple of ways to import data using the GUI. I say hopefully this saves you a little bit of time, but the moral of the story is if you're going to use this, use it with care, and make sure that you inspect the code and certainly copy the code into your RMD file before you knit it.